Algebra 2, 7-3, logarithms and logarithmic functions. All right, here's something new for Algebra 2. Here's an example. I've got log base b of x. Notice how log and x are on the same line and b is down here below. Equals y. If and only if, remember if from a while ago, b to the y power equals x. Okay, what does all of this mean? That is a mess. So let's see what this means. We can change a logarithmic, so these two forms here, this is the logarithmic form, this is the exponential form. And they are the same thing, and we just configured them in a different way. These are saying the same thing, or these are equivalent equations here. I don't know how to exactly say that the right way, but we can take a logarithmic function and we can change it to exponential. And so here's how we do this. If I have log base 2 of 8 equals 3, here's what I do. I take this 3 and I jam it up, pop, in there between the 2 and the 8, and the 8 falls out over here. So I end up with 2 to the third power, the 3, remember, jammed up in there, bumped the 8 out, and so the 8 landed over here on the other side of the equal sign. That's one way to look at it. This is the way that makes most sense to me. It's the easiest for me to understand. 3 jams its way up in there, the 8 falls out to the other side of the equation. Now, another way you can do it, if this makes more sense to you, go ahead and use this. It doesn't matter to me. Is to take this 2 and do like a snail shell thing, and it lands over here. So you end up with the 2 comes around and goes underneath the 3, so you have 8 equals 2 to the third. So that's another way to do it. If that makes more sense to you, that's fine. Go ahead and think of it this way. This way makes more sense to me. It's easier for me to understand. Do it however you want. Okay, let's do some more examples. So I've got the log base 4 of 1 over 256 equals negative 4. So I'm supposed to change this to exponential form. So I'm going to take this negative 4, I'm going to jam it up in there, and I end up with 4 to the negative 4 power equals 1 over 256. 4 to the negative 4, so that means that negative there puts 4 underneath the fraction line, and then 4 to the 4th power is 256. So this is a correct statement here. You try. Log base 4 of 16 equals 2. So let's do another one too. Let's do 2 of these. You try. Log base 3 of 729 equals 6. So rewrite both of these as exponential functions, and then or equations. We'll see how you did. Go. All right. So I take this 2, boom, jam it up in there. 16 falls out the other side. 4 squared equals 16. That's true, right? 4 squared equals 16. Take the 6, boom, jam it up inside here between the 3 and the 729. We end up with 3 to the 6th power equals 729. And that's the way it goes. That's the way to do that. Now, let's try the reverse, all right? We're going to change to a log. And I'm just using log as short for logarithm. Okay, so that's what I mean by log. I don't want to write logarithm every time. Okay, example, here it is. 15 to the 3rd power equals 3,375. Okay, so what I'm going to do here is I am going to take this 3375 and jam it up in there. And when I do that, this 3 falls over there again, just like it did before, but the 15 gets jammed down. So what happens is I get log, the 15 falls down to the base, and then I've got 3375 as right there on the same line as the log equals 3. So same kind of idea. This guy gets mad, gets squished up between them. The one on top falls over, and the other one just squishes down. So you try this one. 4 and to the power of 1/2 equals 2. So change that to logarithmic form. All right, so what you should have done is taken this 2, jam it up in there. You end up with log base 4 of 2 equals 1/2. There it is. Now we get to do some more fun stuff with logs. We're going to evaluate logs. So keep in mind, logs are just another form of exponential functions. So it's just another way to say, another way to write this exponential form. Okay, so keep that in mind as we do some of these things. Log base 16 of 4 equals y. So we're going to evaluate this log. And what we're doing here is we're trying to find what log base 16 of 4 equals. So we're just trying to find y here. So sometimes you might see evaluate a log, and it'll just say log base 16 of 4. And it says evaluate this log. And so I say equals x, or equals y, or equals a, or whatever it is. And that helps me to know what I'm trying to find. I'm trying to find the value of this log. Okay, so here we have y. I'm going to take this y, jam it up in there, and I've got 16y equals 4. Okay, now I need to find, okay, what would my y value be here? Let's figure this out. So back in last 7-2, I think it was, we looked at making the bases the same. So 16 is really 4 squared, and then I have to keep that y up there, equals 4. Remember 4, this is 4 to the 1 power. So I multiply these because y is the exponent here. So 2 times y, because y is, this 4 to the 2nd power is raised to the power of y. So we multiply those. 4 to the power of 2y equals 4 to the 1. And now I just ignore the 4's because the base is the same. 2y equals 1, divide by 2, y equals 1/2. Should I write? Well, that's fine. Okay, y equals 1/2 is your answer there. Okay, now let's do another one. Let's do it right here. This would be a wee try if we were together. Okay, log base 3 of 81. So now I'm being asked to evaluate this log. And so I look at that and I go, I don't know what the heck I'm supposed to do with this. But if I say equals x, then I go, oh, okay, I just need to find x. Okay, so that's what I'm going to do. Take this x, jam it up in there. I've got 3x equals 81. 81 is 3 times 3 times 3 times 3, right? So 3x equals 3 to the 4th power. That'll give me 81. So I can ignore the bases now since I got them to be the same. X equals 4. All right, you do one. Log base 1/2 of 256. All right, so evaluate this log. Hint, say equals x and solve for x. Okay, go. All right, see how you did here? So I'm going to say equals x because that's how I got to do it in order to be able to evaluate this thing. Jam x up in there, I got 1/2 to the x power equals, I should go like this probably, 256. Ooh, that's gross. Okay, that's all right, I can handle this. So what I need to raise this to the power of -1 in order to get this to be 2. So I'm going to say 2 to the power of -1, that is 1/2, right? That's the same as 1/2. 2 to the power of -1 is the same as 1/2. All right, raised to the power of x equals 256. So 256 is 2 to the 8th power. 2 times 2 times 2 times 2, whatever, every 8 times, that'll get me 256. And so now I almost have the bases being the same. I need to multiply this -1 and this x. So I have 2 to the -x equals 2 to the 8th power. Now I can ignore the 2's and I have -8 equals x. And I just need to multiply both sides by -1 so that I get x actually by itself. X equals -8. There we have it. All right, that's now we are going to shift gears into graphing logs. Whoa, okay. Graphing logs, logarithmic functions. Okay, let's look at the parent graph. Excuse me. The parent graph looks like this. F of x equals log base b of x. That's it. Yep, okay. Now, b cannot be 0. And we're looking at this one where x is greater than 1. And if it's greater than 1, then we're going to have exponential growth. And so we're going to draw this. And the way this works, the way a log works, is it's the inverse of what an exponential function would look like. So if you had the normal exponential function, the parent graph would look like this, where y equals 0 is the asymptote. With a log, though, if I were to draw x equals y, or y equals x, sorry, that line there, and then if I turn it this way, it might be a little bit easier, and then I draw a mirror image, a perfect mirror image, look at that, of this exponential function, then I get my logarithmic function. And so it looks like this, just like that. And in this case, x equals 0 is the asymptote. Okay, now let's look at the other one. Let's look at the decay here. So f of x equals log base b of x. B, again, can't be 0. And x is greater than 0, and it is less than 1, meaning it's a fraction between 0 and 1, and this is going to look like decay. So let's look at what that looks like. So remember, exponential decay looks like this, something kind of like that. Oh, I didn't do that awesome, but there it is. And then I'm going to draw my y equals x axis here. Okay, and then I'm going to look at this way because it's easier for me. And then I'm going to say, okay, a perfect there we go. There it is. So this is decay. And so you could look at it, well, no, let's not do that. Okay. Again, the asymptote is x equals 0. And let's graph some stuff. Example. So I've got f of x equals log base 5 of x. Okay? Now, here's what I'm going to do with this. I could try to graph this. The book goes through, I think it goes through a different way than what I do, because I found this way and I think it works way better. And so what I do here is I say equals y. And then I jam this y up in here and I end up with 5 to the y power equals x. Remember, the x plops over the equation and stuff. And so the book tells you to switch these two and then graph it and then flip it over the x equals y axis. I don't do that. I don't think that's quite as easy as just saying, making a t-table, as you would anyways, but this time you're not taking the inverse, you're not flipping it, you're just going straight to where you want. So you're just going to graph what you're going to get here. And so here's what I do. I plug in my y values and find my x values. Usually we plug in our x values and find our y values. But since we have this set up, I'm going to plug in my y values. It's going to be way easier. So I'm going to plug in -2, -1, 0, 1, and 2 for y and find out what I get for x. And I'm going to keep my t-table just like this, the way I normally do, and so I'll be able to read my points really easily. So -2, if I plug in -2 for y, I have to flip y over, flip 5 over the fraction bar, and I get 1/25. 5 to the -1 is 1/5. 5 to the 0 is 1. 5 to the 1 power is 5. 5 to the second power is 25. All right, so I am now going to draw this thing. And so let's see, when x is 1/25, y is -2. So that's like right here along that line. When x is 1/5, y is -1. So that's still very, very close. When x is 1, y is 0. When x is 5, 1, 2, 3, 4, 5, y is 1. And then with 25, it's 2. So I'm going to draw this coming up like that. There it goes. So I'm going to look at my domain and my range and my asymptote. So my domain, it's my x values. There aren't any over here. So they don't start until just after 0. So soft bracket at 0 to positive infinity. My range goes all the way down, goes all the way up. So my range is -infinity to positive infinity. My asymptote is right here at x equals 0. Okay, let's do a u-try, sure. F of x equals log base 4 of x. All right, so just follow what we just did here and graph this thing. All right, go. All right, let's see how you did here. I'm going to put equals y. I'm going to jam that y in there, and I end up with 4 to the y power equals x. Then I'm going to make my t-table. I'm going to plug in some good points. And then, let's see, so 4 to the -2, that gives me 1/16. 4 to the -1 is 1/4. 4 to the 0 is 1. 4 to the 1 power is 4. 4 squared is 16. All right, when x is 1/16, y is -2. When x is 1/4, y is -1. When x is 1, y is 0. When x is 4, y is 1. And then we got 16 way over here when y is 2. So draw this guy, boop. And that's what it should look. So it looks very, very similar to this one, right? Almost the same, very similar. And so let's do domain and range and asymptote. So your domain is starting just after 0 to positive infinity, range all the way negative, all the way positive, negative infinity, positive infinity. And your asymptote is x equals 0. This line right here, this will never touch. All right, good. So now we're going to look at some transformations, just briefly, of the logarithmic function. So I've got f of x equals a times log base b of x minus h plus k. So this should look pretty familiar to what we've looked at before. So a, if it's negative, reflects on the y-axis, or on the x-axis, I'm sorry, x-axis. And then it flattens and stretches just like we looked at on the other functions. So if it's a fraction, it squishes it. If it's between 0 and 1, squishes. If it's above 1, then it's gonna stretch it this way. Okay, x, here we go. The x minus h here, that's the horizontal shift. So subtraction goes to the right, addition goes to the left. K is the vertical shift. Ooh, that's a gross word. Okay, vertical shift. And so positive goes up, negative goes down. So those are your transformations here. Let's do one example. 3 log base 10 of x plus 1. Whew. Okay. All right, so b is a number that is not a fraction between 0 and 1. So your parent graph is going to look like this, the exponential form of the log function. And then it's going to move to the left 1 space. And then the 3 is going to do something to it too. But let's do a t-table and let's graph it and let's look at it. So I've just told you what's going to happen here. It's going to move over to the left 1. Let's see what this 3 does to this function here. Okay, so let's go -3, -2, -1, 0, and 1. Let's see, am I going to do all those? Sure. 1, and let's do 2 as well. Okay, so let's see if we go ahead and start plugging those things in here. Oh, that's gonna be a pain, isn't it? Let's go ahead. Oh, that's fine. If I plug in 0, I get log base 10 of. We're not ready to do this yet, are we? So let's just do the. Let's just do it based on the transformations. Sorry. Okay. So we move this over. So here's my x equals 0 is my asymptote. I'm going to move that to the left 1. So my new asymptote is x equals -1. And so my graph is going to go through here, like that. Now, this 3 here is going to make it either squish this way and up or this way and out. And so that's what it's going to do. So the 3, if that 3 is there, it's going to make it go like, it's going to squish or elongate vertically. It's going to make it go like this and squish in like that instead of spread out and squish that way. So it's going to go like this. It's going to go like that. So if this is my other parent, part of my parent, this is the one that we want to look at. And that is how you're going to graph that one until we figure out how to do. We're not going to do this because we don't know yet how to handle this. And that's okay. So we use the parent and the transformations. And that is it for logarithmic functions for this section of it, 7-3. We'll be looking at logs quite a bit more as we move forward. All right, good luck on the homework.